Okay, so I've given you an extra copy of the unit circle that's in your notes because you may find the one we write on today, we're going to make notes all over it, it's going to be kind of ugly, those sort of things. You may want to make a better copy or a less messy copy to kind of keep in your notes. You can get some amazing printed off unit circles from the internet too, with some handy tips and tricks on them. So don't be afraid to Google unit circle, complete unit circle. I have a bunch. There's one that I found that had some really fun stuff in it, but we'll get there. Okay, so we're gonna, again, why is it called the unit circle? What's the radius of it? 1 unit. 1 unit is the radius on the unit circle. Okay, so with all of that said, we call them special triangles because there's lots of values on the unit circle, but we are going to just stick with some very, very special ones. Okay, here we go. And we're going to do it in degrees and radians. Let's go here for a second. Can you guys pop to this page for a second? Okay, let's put on the angles that we know in both degrees and radians of the x and y axis. All right. So 0, do you want to do it in all radians first? Maybe let's do it in all radians. So 0, and then at 90 degrees, what is it in radians? Pi over 2. And at pi, or I, 180. Sorry, I ruined the fun for that one. What about at 270? 3 pi over 2. And then when you come back all the way around, you've gone 360 degrees, 2 pi. Okay. So, how many of you remember that from however many days ago we started this? Sort of, kind of? Okay, those are kind of really important benchmarks that you have to commit to memory. Let's do quadrant 1. All right. You see all these, and I put these different lines on. I had to make this circle. Pretty proud of myself. Halfway in between 0 and pi over 2. Halfway, right here. Ooh, what? 45 degrees. I agree with you, which is pi over 4. All right. So if I take my 90 degrees and I cut it now into 3 sections, section 1, section 2, section 3. What's the angle measurement here? In degrees. In degrees. 30. 30. So what is 30 degrees in radians? Pi over 6. Okay. What's 60 degrees in radians? Pi over 2 is here. Pi over 3. Okay. Like I said, we're going to make a mess of this one. That's why I handed you out an extra one. So think of this one as your rough copy. So feel free, and if you need extra copies of the unit circle, I've got them. Okay, so let's now put the degrees on top of those. I'm just going to switch colors for a sec. We said pi over 6 is 30 degrees. Pi over 3, I'm going up top here for a second, 60 degrees. So this is how I remember it. I remember it as opposites. Base is 6, so this one's 30. This is a base of 3, so this one's 60. That's how I connect them in my brain, is that they're opposites. We said that pi over 4 is halfway, so that one's going to be 45. Do you need to put the angle measurements on the axes, like the 90, the 180, the 270, and the 360? If you do, please go ahead and do it. I think I'll just leave mine without them right now, because those are just the angle measurements. We're now going to be putting coordinates on them as well. Super fun. You're going to be so excited by this stuff. Okay, here we go. Today's lesson is we're doing the coordinates of these points. Where does that point lie? Where does this point lie on the coordinate plane? Where does it lie on the circumference? So we're looking for the x, y values today. That's what we're doing today. 4.1 was figuring out the degrees. And you guys are like, I barely have 4.1. I barely figured out the degrees. And today I'm going to add to it. Today we're going to put the coordinates. This is just that angle measurement in standard position, leaving off. That's what we did in 4.1. Now today we're doing the coordinates. And I think sometimes people get those mixed up. Like pi over 4 is an angle measurement. A coordinate is a location on the coordinate plane. And on this time it will be on the circumference of the unit circle. Okay, special triangles. I do this in hopes to make the connection that you already have this information. Start with an equilateral triangle with side lengths of 2. Equilateral triangle, side lengths of 2. Can you guys draw me a picture? Equilateral triangle. What do we know about equilateral triangles? All sides are the same, and what about the angles? They're all 60 degrees. They all have to be equal as well. Did you draw it?
Yeah.
If I were to look, would there be an equilateral triangle there?
Yeah.
Sweet. Oh, things are happening that I hadn't anticipated. That is not an equilateral triangle. What is that? I would say probably it was an isosceles. The two sides were the same. Where did I go? I don't know if my eraser works on these things. No, it does not. I'm trying to hit the undo button, but that added something.
Hit it again.
Okay, you guys are just Mr. and Mrs. Know-it-alls. Okay, fair. All right, I was a little salty on that one. Okay. Everybody good with that? Everybody good with that? Okay, so your triangle looks something like it? And we know that this should be 60 here, 60 here, and 60 there. Okay, so now it says to mark in the height of the triangle. This should create 2 right angle triangles. You guys agree with me here?
The height is 70, like one of the sides.
Ooh, what? Crazy. Crazy.
No, that's really what's wrong?
Oh, that's fancy.
YouTube is half inch. So I go, YouTube has a length of 2.
Okay. So we do have a couple units to measure. So let's take this right angle triangle. Let's just take that one for a second. We know some things about this right angle triangle. What do we know about this right angle triangle? Tell me everything that you know.
Right angle.
It's got a right angle. Good job.
Right.
It is a triangle. 3 sides. Solid. I'm glad you made it to grade 12 pre-cup.
The bottom is 1.
The bottom is 1. Smart. That's what I wanted. That's what I wanted. There's one other piece of information I want from you guys.
The top, I think, 30 degrees on the top.
30 degrees on the top. Okay. That is what makes you mathematically elite. Right there. Dividing 2 by 2 and getting 1. Dividing 60 in half and getting by 30. really you're already there. So I'm just going to look at this yellow triangle because you've seen it before. So, oh, sorry, if this is 60 right here, you've just drawn in your height. That's not as good as I'd hoped. Let me look. Let me do this here. That's my attendance. Okay, unit circle, right? You guys told me that this angle here was 60 degrees. You guys told me that, right?
Yeah.
That's what you just told me? There's a right angle triangle right in there. We're going to be doing these right angle triangles based off this. Okay? Now, this is a little bit different because this has a radius of 1, so its hypotenuse would be 1. We're working off a hypotenuse of 2, but they're all related. They're similar triangles. Okay, Rahat, what are you working on, bud? Okay. There's so much movement with you, it's hard to keep up. All right, let's do trig ratios for this. I want you to do sine of 60, cos of 60, tan of 60, and then I want you to do sine of 30, cos of 30, and tan of 30. Nope, I want you to leave it as fractions, please and thank you. Nobody should have their calculators out. So right angle triangle, so we're going back to the sine, cosine, tan, opposite over hypotenuse, adjacent over hypotenuse. What's my hypotenuse? The hypotenuse is the same whether I'm looking at the 30 or the 60. Which number is it?
Isn't it 30?
Your hypotenuse is 2.
Your hypotenuse is the longest side, which is across from the right angle. We know the base measurement of 1. So we know our adjacent is 1 if we're looking at angle 60. What do I need to find out here? I need to find this third side.
Okay.
So how am I going to do that? Pythagorean theorem.
3.
No.
How would it be?
If 2 is the longest side of the triangle, all of a sudden we were mathematically elite, and now we've fallen far. So Pythagorean theorem says a squared plus b squared equals c squared, where c squared is my hypotenuse. So 2 squared equals 1 squared plus b squared. You could have said a squared. Why is this just hopping all over the place? Okay, I hope you guys are doing better with that.
Oh.
Me. I got lazy and didn't calibrate at the beginning of my lesson, thinking no big deal, I just used the board. Turns out it is a big deal. All right. What do we got here? What do we got?
4 equals 1.
Okay. So what's b? Square root of 3. Sorry. I apologize. Okay, now that you know that, now that you know the height is the root of 3, can you do these ratios? Pretty quickly, right? Okay, are those your ratios for 60 degrees, did everybody get those?
You fraction
Which fraction did I do wrong?
10, 60.
Right, I'm just writing it like this so people know where I'm getting, like it is, we usually just say root 3. But we can just, I'm going to leave it like that for the ratio for right now. And I'm not going to rationalize the denominator here. You can if you want to, but I'm not going to. So I will just tell you a rule about rationalizing. Don't do it unless it specifically tells you that you must. And I'm going to tell you in grade 12, we never tell you to rationalize the denominator. You guys remember what rationalizing the denominator means? It means getting the root off the bottom. We practiced that in grade 11, and then in grade 12, we're like, don't do it. So, okay, these ratios are super duper important. Sorry. Do you ever get into a group chat and then they're all buzzing and you're like, I'm busy right now? Sorry. I don't like that. Okay. So we did that. That's going to be important. I want you guys to hold that for a second. Okay, we're going to put this on pause. You guys are great mathematicians. Okay. Isosceles. Isosceles triangle. What's an isosceles? Two sides are the same. It was the first triangle I tried to draw. And it says with legs measuring 1 unit, so those would be our shared. And then we are going to draw that height in again. So what do we know about an isosceles triangle? So two sides are the same. What do we know about the angles? All the same as well. 45 degrees at the shared angles. So these ones here, oh God. These ones here are 45. Okay. How do you feel about that one? How are your reels going, Rahat? Did you get this triangle copied down?
Yes.
Yeah? Sweet. If I were to walk over there, would you be lying to me?
Look at this, Miss Cowan.
Look at you.
First time for everything.
True story, true story.
I'm probably a lot.
Hey, 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 hey. We are all doing our best.
Not wrong if everyone might.
Okay.
Put that on the shirt.
All right. Maybe I gave bad information on this one. I gave bad information on this one. Because if these two are 45, what does this angle need to be? 90. Does that look like a 90-degree angle?
No, it doesn't.
Not really. Maybe let's draw, you guys all did that in eraser, right? Or in erasable pens, or... Okay. I'm trying to draw this the best I can. With the 90-degree up there. It's the exact same triangle, guys. Exact same triangle. Because I needed the 90-degree up top. My other one was too pointy. Well, I just want it to reflect that it actually is 90 degrees up there. No, absolutely not.
What did he have?
I'm going to take the phone and I'm going to throw it out the window.
Please do.
Okay. All right. These were 1 and 1. Okay. We don't need to put a height in this. because it's already got a 90 degree. Okay, it's already a 90 degree. So what do we need to find in this triangle? The hypotenuse. Hypotenuse is always the longest side across from the right angle. This is the one we don't know. So we don't know the hypotenuse. So we're going to have 1 squared plus, oh, my head's in the way. That's supposed to be a plus 1. Okay, you guys figure it out. Square root of 2, thanks. I'm having a hard time over here writing 1 squared plus 1 squared equals c squared. So c is equal to the root of 2. Everybody good with that? Can you guys do the trig ratios on that one? You can do all of them.
We can do 1 set.
You're only going to do 1 set, yes. Because these 2 angles are the exact same, right? So we wouldn't write it twice. We're all gasping. I just thought I'd roll with it as well. Okay, again, I wouldn't rationalize this unless you really have to. And we'll talk about it in a second. Okay, everybody good with this? We're like, what's this right angle trig? We haven't done anything crazy or important yet, but it is all tied together. Would I sign your paper? Oh, I wasn't meaning to. Trust me, you'll know if I'm side-eyeing you. Okay. Okay, the equation of the unit circle.
Oh boy.
Okay, we used to teach circles as an entire unit, and it's sad that it's broken down into one line.
Why don't we do it in one
They changed the curriculum way back in 2012, and they removed circles from it. And it's a sad day, because we did ellipses, we did circles, we did hyperbolas, we did all kinds of different shapes, and we don't really touch on them anymore. But this is the equation of the circle. It's your x-coordinate squared plus your y-coordinate squared equal to your radius squared. And so we know that the unit circle has a radius of 1, because we've already been through that. So I just put 1 squared there. But really, this should be radius squared. So if you meet a troll who won't let you pass and wants to know the equation of any circle, it's going to be an r there. Yeah. Yeah. I think this might be on your formula sheet, though.
You don't want to have to remember what x equals plus 5.
Nope. This is not on your formula sheet.
Yay.
Yay!
We're going to have to remember it's a full curve.
You're going to have to remember it yourself.
Well, that's
Not too, like, it's not too hard. Just know that the 1 on it isn't always there. It's the radius. So just in this case, it's the unit circle. Okay. I left an awful lot of room. Okay, you guys ready? You guys ready? What do we know the radius of the unit circle is? You guys know that is 1, correct? Yes? Yeah, radius on the unit circle is 1. We know that this coordinate pair would be, oh, geez Louise. XY, you guys would agree with me that this point on the circumference is just a random XY? Mm-hmm. Okay, let's do trig ratios. I think I heard that, but I don't think I understood it.
Agreed with Scallion, same feeling.
All right. So let's look at that right angle triangle I just drew onto the unit circle. You guys would all agree that the x coordinate would measure over to here, and the y coordinate would measure over to here. We've done this a million times now, we've just dropped a circle on it, and then everybody loses their mind and loses all their knowledge. Okay, so we know that this would be the x, and the height would be the y, right? On that triangle. So we've never really looked at coordinate pairs this way, but really it's not a stretch. We know our angle is measured between the initial arm and the terminal arm, so it's always going to be measured around the origin. And it's always going to be measured off the x-axis, never the y. Always measured off the x. Okay, let's do the trig ratios here. We don't have any data, but just go with me. We're just going to do the trig ratios. We have a 1. The 1 is the hypotenuse. Unit circle. So what is the ratio for sine?
Y divided by 1?
Okay, so what's our opposite side? Y. And it's divided by 1. Cos theta, x over 1. And tan theta, y over x. All right, so you guys just learned a really important thing there, and you might not have connected the dots yet. We know that sine of any angle on the unit circle is equal to the y coordinate. And we know that on the unit circle, any x coordinate is cos. So any point on the unit circle can be represented by cos theta, sine theta. Because really, cos theta is equal to x, and sine theta is equal to y. So any coordinate pair would go cos, then sine. Think of it alphabetical order. Okay, cos, then sine. X, then y, alpha order. I know we always say it's sine, cos, tan, but in this case, cosine is the x, and sine is the y. And tan can be written as y over x, sine over cos. Do you see how this might relate to those two things we just did before?
No.
I'm going to pop back here for a second. What's sine of 60? Root 3 over 2, right? Is that the x or the y value? The y value. So at 60 degrees, it has a y value of root 3 over 2. It has an x value of 1/2. So your coordinate pair will be 1/2 root 3 over 2. So these are the things that you need to remember. You need to remember these ratios. Now, sine and cos are on the unit circle, and you'll use that information to find your tan. Okay. Okay. Here we go. We're going to fill this in. We are going to fill in today the coordinate pairs. Okay. The whole unit today? Yeah, it's just another page. Yeah. That's it. We're good. It's only 10:30, folks. All right. We're going to fill this in. We're going to do the coordinate of 30 degrees. Coordinate of 30 degrees. So you might need to flip back and forth between the first page and the second page. What comes first, cos or sine?
Cos.
Cos. Cos is your x. So cos of 30 degrees. It's on your first page. If we go back here, what's cos of 30 degrees? Root 3 over 2. I don't even know what page I'm on. So my cos is root 3 over 2. What's my sine? What's my sine? 1 over 2. Okay, these are the numbers you guys need to remember. Root 3 over 2. Oh. That's supposed to be I said root 3 and then I wrote 2. Root 3 over 2, 1/2. 1 over root 2. Those are what you need to remember for the unit circle. This one, I don't know why I've rationalized it in my head. So you will also hear me say root 2 over 2. I've just rationalized it. So I tend to flip-flop back and forth between these two, but really, you need to memorize those 3. That's it. Now, with those 3 things memorized, you need to know how to put them in what order. Okay, let's jump to 60 for a sec. Let's go to 60. We're just going to skip 45 for a second. So 60, what is my cos? 1 over 2. Yeah. And then my y is root 3 over 2. Now these are the coordinates of where this point on the circumference is actually located. Okay, 45. 45. 1 over root 2. And 1 over root 2. If you can remember quadrant 1, you can math everything else out in this circle. Because we are going to do these points for everywhere. Okay? Pardon? Kind of. But there's some rules to it. Okay, let's go back and put some angles on here. You guys remember that these slices of the pie, how much is that slice of the pie worth? 30, right? That slice is worth 30. So what's 90 plus 30?
110.
Okay, 120. So we know the degree measurement of it. What's 120 in radians? You need to figure it out.
It's over 2.
Logan, where'd you pull that from? The cheese wheel? On what page? 4.1? 4.1, the cheese wheel? That's okay. No, he's using a resource. He's using an available resource to him. Okay. We know that's 120 degrees. Oh. All right. I'm going to skip 45 for a second because I'm going to go another 30. So what's 120 plus 30?
150.
150. Okay. What's that as a radian? 5 pi over 6. Let's go back to our 45. What's 90 plus 45? 135. So what's 135 as a radian?
Use my resource.
3 pi over 4.
I knew that one.
3 pi.
Now, you can do the conversion by multiplying by pi over 180. You could be doing that conversion. You could be looking at 4.1. It has them all on it already. What do we know? We're trying to get to pi here, right? So let's count for a second. If we are counting by quarter pies, so 1/4 pi, 1/4, let's just drop the pi for a second. 1/4, 2/4, which is a half, right? 3/4, 4/4. So knowing that, what's this one? If this one's 4/4, this one's going to be 5 pi over 4. And then this is going to be 6 pi over 4. And then this one will be 7 pi over 4. And then if you go all the way up here, it's going to be 8 pi over 4, which is equivalent to 2 pi. Okay, so common denominators is helpful. You want me to stop moving it?
Yeah.
Okay, either way, not okay with this. All right, so if this is 5 pi over 6 here, what's this one? 6 pi over 6. And 6 pi over 6 is just 1 pi. So what would that be? 7 pi over 6. I don't know.
Oh, I looked at the wrong one, that's why.
Okay, so if this is 7 pi over 6, what's this one? 8 pi over 6, but we're not going to write 8 pi over 6. 4 pi over 6.
Yeah, that's my moment. Okay,
So if this one's 8 pi over 6, reduced to 4 pi over 3, what's this one?
3 pi over
9 pi over 6. This one's going to be 10 pi over 6. Am I going to write 10 pi over 6? 5 pi over 3. So 10 pi over 6. This one is 11 pi over 6. And then this one up here would be 12 pi over 6. So you can map out the rest of that unit circle. Okay. Now, here's where we get to do the coordinates for all of them. What do we know about the x coordinate in quadrant 2? It's negative. So really, it's going to be these coordinates again, but you need to know where you are on the coordinate plane, and we know that all of our x coordinates in quadrant 2 will just be negative. So here's the deal, ladies and gentlemen. If your fraction has a denominator of 6, it will be that coordinate pair. If your fraction has a denominator of 6, it will be that coordinate pair. But we just got to change one thing on it because we're in quadrant 2. What's going to happen to my x? It's going to become a negative. Okay, if it has a denominator of 3, it's going to be that same coordinate pair, but it's going to have a negative for x. Del, are you with us? Okay.
We slow down a bit.
Oh my goodness, you guys. I'm not slowing anything down because you spend your time bickering like old ladies. Or old men. bickering like old people.
I didn't do anything.
What are we doing at that place again?
I'm enjoying myself.
Then you bicker like the old men Muppets in the balcony. Okay, that's what
I didn't find out that.
you identify as Muppet. Okay, all right. Again, if it has a denominator of 4, same coordinate pair, but because we're in quadrant 2, your x is going to be negative.
What are the chances it's gonna be specific number?
100%. This is why you need to memorize the unit circle, because we're going to use these exact values when we're solving equations and things like that. This is where I can take your calculator away from you. Because you know that sine of 60 degrees, what's sine of 60 degrees? You do. It's on the coordinate plane. Is your x or your y sine? Your y is sine. Your y is sine. So what is sine of 60 degrees? Root 3 over 2. So you now know these exact values. This is why I can take your calculator away and you can just work in the radical fraction world. You can.
And we're in one lesson. It's gonna be stuff that.
Oh, what's this coordinate pair? I didn't do this just because it's pretty obvious. What's this coordinate pair?
Pretty much,
I don't want the 0, 1.
So, Ms. Gallion,
Yeah.
when we get to the assignments,
Uh-huh.
are there gonna be assignments in there that I'm gonna be able to look back into the notes?
When we get to the assignment, there are.
Shut up. Shut up.
Okay, Stephen, he is trying to ask a question that I don't. So what, are there questions in here? Like, you need to know how this works. Because if you look back at this completed thing and you've missed the entire lesson, this unit circle isn't going to make a ton of sense to you. But if you've been paying attention and you understand how the unit circle works, or even if you weren't paying attention, go watch a YouTube video on the unit circle. There's a million of them out there. But if you just go back and look at this, it's not going to make much sense. It's the explanation that comes with it. What's the coordinate pair at pi? Okay. Denominator of 6. Denominator of 6. And we're in quadrant 3, so both are going to be negative, negative. So this one's going to be negative, sorry, that's not a very good root sign. Negative root 3 over 2 and negative 1/2. Denominator of 4. Negative 1 over root 2. Negative 1 over root 2. Denominator of 3. Are you guys getting to see the pattern? Like the pattern keeps following all the way through, so it makes it it makes it repeatable, and you can math it out. 3 pi over 2. Sorry, Tristan? Yeah, because you guys complain the whole time.
I won't, no, I was not playing that. I mean, we won't, we didn't vote.
Yeah, shut up.
Yeah, even though they're supposed to,
Quadrant 4, what's going to be negative? The y this time. This is not right.
Yeah, stupid.
And when you guys don't know what's going to go on, I'm going to refer back to what you two are doing.
I was doing it.
I'm well aware of that.
You too. I'm not asking how much time we got left. I said 20 minutes. And
You guys were complaining about stuff.
I didn't complain about it. I know I'm good.
You do?
Yeah.
Okay.
Like what? Yeah. Eight plus two. Why did you do that?
Well, the last time I find like unit circle value like close one, I think.
Where's cos 1, where is 150? Right here. What's cos? Is it your x or your y? It's your x. So what's the cos of 150? Root 3 over 2. That's why we can get rid of our calculators. Okay, this one is going to be root 3 over 2 and negative 1/2, and this point here will be 1 and 0.
Good job.
Thanks, I worked hard on that. Okay,
It's a good job.
this is how somebody showed me this. Somebody showed me this a little while ago, and I found it helpful to remember, like, 1/2 and root 3 over 2 go together as a pair. It's just what order do they happen in? That gets confusing and can mess you up. So this is how somebody showed me how to remember it. There's lots of tips and tricks on YouTube if you want to go find something else. But if I look at this triangle, and there would be my right angle, what side is bigger? Is it the x or the y? X is a longer side. What ratio is bigger? 1/2 or root 3 over 2? Root 3 over 2. So this is a long, short. So I know that my x will be root 3 over 2, and my y will be 1/2. Because the y is shorter than the x is long. And then if I do this one, if I do a 60-degree one, what's shorter? The x now. So my x is 1/2, and my y is root 3 over 2. So I end up drawing the triangle, because for me it helps to link it to something visual. So I know my bottom, my x is short, so that's a 1/2. My y is long, so that's the root 3 over 2. And I just need to figure out what quadrant I'm in, which will tell me which one's positive, negative. So I call them, that's my short, long strategy on how to do that. It might be something to help you guys as you're learning to memorize. If you can do quadrant 1, if you can commit quadrant 1 to memory, you can do all the other quadrants from the pattern.
Sounds good.
Perfect. Okay. We're going to pause on the unit circle for a second. And we're going to see if this point lies on the unit circle. This is the formula from your unit circle. Well, from the values of the coordinates on the unit circle. All you're going to do, ladies and gentlemen, is you are going to substitute these values into the equation and see if the left-hand side equals the right-hand side. It's pretty straightforward. So root 5 is my x. Root 5 over 5 is my x. I'm going to square that. Plus 2 root 5 squared should equal 1 if it is a point on the unit circle. If it doesn't equal 1, then it's not a point on the unit circle.
Wait.
Is that a true statement? Yes. Yeah. Is that point on the unit circle? Yes, it is. Okay. So even though it's not one of the exact ratios that we use, there's lots of other points. Hey, zip it.
That wasn't even drawing.
His reaction. Then move. Okay. All right. So this next part is we're going to say the point is on the unit circle. We're going to use It's like Pythagorean theorem. You're just going to find the missing side, and you just need to do the cast rule to figure out where you are. Okay, so here, determine the missing coordinates for all points on the unit circle. So we know it's on the unit circle. The question has told us it's on the unit circle. We just got to figure out why. There's no restrictions here. There's no restrictions. Okay? So we'll go through. All right, so negative 5/8 squared plus y squared equals 1. Oops. 16. Oh, 64, you're right. I don't know why I was going with 16.
By itself. So this one makes more sense.
What?
Okay. So what's left here?
Well,
What's 8 times 8?
that's 64.
Okay, what's 64 minus 25? 39? All right. So I don't want y, I want y squared. Or sorry, I don't want y squared, I want y, so I got to square root both sides. 39 obviously isn't a perfect square,
But 8 is.
but 864 is, so you can say root 39 over 8. But we're missing something here. What's the most important? Positive and negative, because we don't know where we are. It didn't give us any restrictions.
Well, what?
Where do we, what 2 quadrants do we know we could potentially be in? Sorry? 2 and 3, how do you know that? Because the x is negative. So we know with the x being negatives, we could be in quadrant 2 or we could be in quadrant 3. If we're in quadrant 2, this is positive. If we're in quadrant 3, this is negative. Nice. Okay, last one. This one's giving us a restriction. Yep, sorry? No, it's just a plus minus here. Yeah. Okay, so we're going to do the same thing here, but it's given us a restriction. It says the point is in quadrant 2. So what do we know automatically about our x? Has to be negative. So we know our answer isn't going to be plus minus this time. It's only going to be negative because it's given us that statement. So we're going to have x squared plus 5 over 13 squared equals 1. Over 13. We always default to the positive principal root, but this is telling us we're in quadrant 2, so we know that our x must be negative.
I put negative sign behind
That's no good.
No, because that indicates that you're trying to subtract something from it. Okay, that was a